Hi, I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of measurement within the Year 11 standard course, and we're looking at measurement and energy, which comes under MSM1. So in this video, we're going to have a look at accuracy within measurements. So when we take a measurement, it is just an approximation. It won't be accurate, 100% accurate, and so we'll have an error, which means we need to give it a leeway or a range of accuracy. So for example, if we're having a look at a centimeter ruler and we're using that to measure something very small, we could measure the length of an ant to be 4.25 millimeters. But the actual measurement could be 4.4 millimeters. Because we're looking at something that is so small for the human eye to perceive, we can't determine what is 100% accurate. We could give an approximation where it's close to 4.25 millimeters, whereas it actually might be 4.3 millimeters. So we give it a leeway or a range, either side of the actual measurement. And so if we say our measurement to be 4.25 millimeters, we'd give it a upper bound number and a lower bound number. And in between the lower bound and upper bound will be a range that we say is accurate. So say your measurement of the ant was out here, we would say that's inaccurate. But say 20 people got different measurements all within this range, we could say they are all correct, because it's hard to actually tell what the 100% accurate measurement would be without something like a microscope, for example. So that's why we do accuracy in measurements, because every measurement's going to have a little bit of an error. So when we're doing accuracy in measurements, there's 4 things, well, there's 6 things that you need to know. 4 of these things will be on your HSC formula sheet. And so you need to remember them for year 11, but you don't need to remember them for year 12. You just need to know how they work. The other 2 are not on your year 12 HSC formula sheet, so you will have to remember them. So firstly, when we're doing accuracy in measurements, we need to find the precision. And the precision is the smallest unit on a measuring instrument. So for example, if we have a look at a centimeter ruler, the smallest measurement on a centimeter ruler is going to be 1 millimeter. So it's just the smallest unit of measurement that we can see. Then once you've found that, you can then find the absolute error. And the absolute error is half the precision or half the smallest unit of measurement. So if we were going off our example from the centimeter ruler, we would do 1/2 times by 1 millimeter, and that's going to leave us with 0.5 millimeters. Once you've found the absolute error, you can then find your range, which will be your upper bound and your lower bound. So when we're doing our upper bound, we find the measurement, which could be 4.2 millimeters, and we add our absolute error. When we're doing the lower bound, you get your measurement and you minus the absolute error. So these 4 things, you have to find 1 first and then 2. Once you found 1 and 2, you can then find 3 and 4. And they give us our range of accuracy when we're looking at a measurement. So now let's have a look at the next slide. And remember, these 2 are not on your reference sheet, so you do have to remember these 2. The first one is relative error, and the second one is percentage error. So relative error is the absolute error over the measurement. And remember, the absolute error is half the precision or half the smallest unit of measurement. The percentage error is the same as the relative error, except we times it by 100 to get a percentage. So let's have a go at doing an example. So here we have a ruler, and we can see that we have millimeters marked on this ruler. So if this is 10 millimeters, it would leave us with 1 centimeter, 2 centimeter, 3 centimeter, etc. So question A says, what is the length indicated by the arrow on this ruler? So if we have a look here, the length is measured there. We have 35 millimeters, 36, 37, 38. So the length indicated by the red arrow is 38 millimeters. Question B says, what is the precision? So this is where you have to think, and you have to think in your head, what is the smallest unit of measurement that I can see? And we can see millimeters, and the smallest one I can see is 1 millimeter. So if I was to look here, the smaller line represents 1 millimeter, and that's the smallest unit of measurement I can see. I can't see nanometers or any other type of smaller unit of measurement. The smallest I can see is millimeters, and so we're going to say that 1 millimeter is the precision. Now question C says, what is the upper and lower bound for each measurement? So remember, before we can find the lower and upper bound, we have to find the absolute error. That's our second step in the process. So the absolute error is half the precision. And so our absolute error is going to be half times 1 millimeter, which is going to be 0.5 millimeters. So our upper bound is going to be our measurement or our length plus the absolute error. So our upper bound, might do it down here so we have more room. Upper bound is going to be 38 plus 0.5, which leaves us with 38.5. And the lower bound is going to be 38 minus 0.5, which is going to leave us with 37.5. So although the actual range, the actual measurement indicated by the arrow was 38 millimeters, our range of accuracy is going to be 38.5 to 37.5. So anything in that range we would say would be correct. Then question D says, find the relative error. So we know the relative error to be the absolute error over the measurement. So our absolute error over our measurement is going to be 0.5 over 38. And if you put that into your calculator for question D, it is going to leave us with 0.013. And finally, the last question, which we'll do up here in this gap here, is the percentage error. And we know the percentage error to be the exact same as the relative error, except we times it by 100. So it's absolute error over the measurement times by 100. So if you times 0.013 by 100, you should get 1.3%.